Good afternoon, everyone. As a continuation from the previous video where I discussed how to solve the x values in a quadratic equation, just as a reminder, we had the expression ax squared plus bx plus c equals 0, where a is a coefficient of x squared, b is a coefficient of x, and c is a constant. And so I did say that in the next video that I would cover the application of quadratic equations, right? So in this particular problem, we are asked to find the dimensions of a room where the perimeter is 46 feet and the area is 120 square feet. Now, looking at this, it doesn't look obvious that it is a quadratic equation, but as we walk through the problem, you get to actually notice it is a quadratic equation, and we will use the same method that we did in the previous video to solve for the dimensions of this particular room that we are given. So let's get started. So now we know that P, which is the perimeter, I'm just going ahead, let me just draw the room just to kind of illustrate how it will look like. So if you have a room like this, where this is the length and this is the width. Now we are told that the perimeter is 46 feet. So what's the perimeter of a rectangle? Is 2 length plus 2 width would give us the perimeter, right? So it's like L plus width plus L plus width. So 2L plus 2 width equals to the perimeter. So we can call it P equals to 2L plus 2W. Now what is the area of a rectangle? Is length times width, right? And we know that the perimeter equals to 46 feet and the area equals to 120 square feet. Now we have two equations now, right? Equation 1 and equation 2. I'll go ahead and rewrite it down here. So I have 2L plus 2W equals to 46, and L times W equals to 120. Now, in order to get a quadratic equation form, I need to rewrite the function, one of these equations, so that is in terms of one variable, so we can solve it. Now, it's completely up to you what you want to start with. I can use the first equation, and I use the second equation to solve for L in terms of W and substitute into the first equation, or I can use the second equation where I solve for W in terms of L and put it back into the first equation. It really doesn't matter. You're gonna get back the same answer. So let's go ahead and, using the second equation, I will go ahead and solve W in terms of L. So I know that L times W equals to 120. So this means that W equals to 120 over L. Okay, again, like I just said, you can solve L in terms of W or W in terms of L. It really doesn't matter. Now, what we'll do is that now we have the value of W in terms of L, we'll go ahead and substitute this value into the first equation. So let's go ahead and do that. So that means, 2L plus 2W, what is W in terms of L? It's 120 divided by L equals to 46. Again, it's still not obvious it's a quadratic equation. Let's go ahead and simplify this one further. So I have 2L plus 120 over L equals to 46. So I will go ahead and move the 46 on the other side of the equation. That way I have a 0 at the end. So I have 2L plus 240 over L minus 46 equals to 0. Now I see that everything is a multiple of 2, so I can simplify this. So I have L plus 120 divided by L minus 23 equals to 0. For this to have a common denominator, I can multiply this one by L. So I will get L squared plus 120 divided by L minus 23 equals to 0. I can go ahead and multiply this one by L as well to have a common denominator. So L squared plus 120 minus 23L over L equals to 0. So this means L squared plus 120 minus 23L equals to 0 because L cannot be 0. So we have L squared minus 23L plus 120 equals to 0. And we do recognize this to be a quadratic equation. So we can go ahead and use our formula. So the first thing I said in the previous video is to solve for the delta first. There are other methods such as factorization, but I'm not going to cover that in this video. So I'm just going to show you the safest route, which is finding the delta and then solving the values of L. Now, in the past example, we had like x squared and then something L, something, and then plus a constant. It really doesn't matter. It's just a variable that we use x. So in this particular example, we have L. So don't get misled by that. So let's go ahead and do that. So what is delta? We said that delta equals to b squared minus 4ac. Now let's go ahead and write our a, b, and c. So what is a? So a is 1, so it's the coefficient that is multiplying the squared, and b is the coefficient multiplying the L, which is negative 23, and then c is 120. So delta will be equal to then what? What's b? B squared is, so negative 23 squared minus 4 times, what is a? A is 1, c is 120. So what is negative 23 squared? So you get, negative 23 squared, you get 529, positive 529 minus, so 4 times 120 should give us 480. So let's take the difference. So 529 minus 4 equals to 49. Okay, so this is our delta. So delta equals to this. Now, we are not done. We need to find L1 and L2. So again, since it's a quadratic equation, you will expect two values for L. So I can erase even this. Okay, so we have L1. So L1 equals to what? We said that to find the values we said like x1 equals to negative b plus square root of delta divided by 2a. And the x2, we said it would be minus b minus square root of delta over 2a. Now let's do that. So what is b? B is negative 23. So negative is positive 23 plus the square root of delta. What is delta? Delta is 49. So that would be the square root of 49 divided by 2a. What is a? A is 1. Just the coefficient of L squared. So 23 plus the square root of 49 is 7 divided by 2. So that would be 30 over 2 would give me 15. So L1 equals to 15. Okay, so what is L2? We're only going to have one length, so but we will solve for both of them to see which one is bigger, because the length should be bigger. And L2 equals to minus b, which is positive 23, minus the square root of delta, minus 49 over 2a, which is 1. So 23 minus 7 over 2. So 23 minus 7 is 16 divided by 2, that will give me 8. So as we can see, we have two values of L, right? So L equals 15 or L equals 8. Since it's the length of the room, it should be the longest. So 15 should be our L. Okay. Now we are not done. We found L, but now we need to find W. I erased it already, but if you remember, we had L times W equals to 120. So we solve that W equals to 120 over L. Now we know L equals to 15, so 120 divided by 15. So 120 divided by 15, this will give me 8. So W equals to 8, which is the width of the room. So 8 feet, and L, we found this to be 15 feet. And to just double check our work to make sure we didn't make any mistakes, let's verify that the area we said that equals to 120, so L times W should give us 120. So 15 times 8 equals to 120. And the perimeter, she said 2L plus 2W. So what is 2L? So 2 times 15 plus 2 times 8. This will be 30 plus 16, which is indeed 46 feet. And as we can see, this matches what we initially started with. So, and that's it to it. Again, like I said, there are other methods that are much faster, called the factorization method. I'll probably cover it in the next videos also, but delta is always the safest route to take. And just to recap, what we did was we wrote our expression in terms of W. First, we started with what we were initially given, which was the perimeter and the area, and then we solve for L in terms of W, or W in terms of L. It really doesn't matter, whatever works for you. If you were to solve W in terms of L, you would end up, you would solve L in terms of W, you will end up at a quadratic equation in terms of W, where you're going to solve for value of W, and then you will substitute back to find the value of L. And then we did the final check here to make sure the values match. So here we have 120 square feet. So yeah, and that's it. If you have any questions, please leave in the comment section. As always, thank you for watching, and don't forget to subscribe. Have a good day.